Alright, guys. This is the notes for 10.0, 10.0, and really we're just going to review rational numbers and irrational numbers. So rational versus irrational. What a rational number is, rational numbers are any number at all that can be written as A divided by B. Any number at all written as A divided by B, where A and B are integers. Now, the number doesn't have to actually start like this. It could start off in a bunch of different ways. So something like 6. 6 doesn't look like it's a rational number because it's not A over B. However, you can turn any number into a fraction by putting a 1 over it. So 6 over 1 is a rational number. Other numbers that don't look like it would be like 3 and 1/7. We can turn this into a mixed, or we could turn this mixed number into an improper fraction by multiplying 3 times 7 and adding 1. So 3 times 7 is 21, plus 1 is 22. So that's 22 divided by 7. That's a rational number. We can also take some square roots. So the square root of 5 times the square root of 5. When you have two square roots, you can multiply the bases on the inside, and this becomes the square root of 25. And the square root of 25 is just 5. So even though our numbers start off as irrational numbers, like the square root of 5, when we multiply another irrational number, we could get a rational number, or a whole number. So those are rationals. Irrational numbers. So irrational numbers, a little bit bigger. Irrational numbers are any numbers that cannot be written as A divided by B. Any numbers that cannot be written as A divided by B. So an example of this would be like square root of 5. Irrational number. Square root of 10. That's irrational. 2 plus the square root of 7 is irrational. If you multiply two irrational numbers, square root of 2 times the square root of 6, you get the square root of 12, which is irrational. So a lot of square roots will be irrational numbers. You also get irrational numbers like pi squared, and cube roots could also be irrational if they have the proper base. So that's irrational numbers. Okay. And you have examples of these on your paper. Okay. So we're going to do a couple of examples real quick. I'll go ahead and head on over to the next one. First thing we're going to talk about is just adding fractions. Negative 1 over 4 plus 2 over 5. In order for us to add these fractions, we need common denominators. So we're going to multiply this guy by 5 over 5. And this one by 4 over 4. 5 times negative 1 is negative 5. 5 times 4 is 20. 2 times 4 is 8. 5 times 4 is 20. So now we have two fractions that have the same denominator. And when we combine them, we get 3 over 20. So just adding fractions. So we took two rational numbers, added them together, and we got a rational number. Okay. So when it comes to adding radicals, adding radicals is really similar to adding things like x and x squared, like x plus x squared or 2x plus x or something like that. So an example of this would be like number 3 on the homework. Yeah, 5 root 13 minus 7 root 13. So if you have 5 root 13s and you subtract 7 root 13s, all we do is combine the coefficients in front, and we get something like negative 2 times the square root of 13. So that root 13 does not change. You could also talk about doing some other stuff. Some more complicated examples would be like number 6. Number 6 is 6 plus 7 root 2 minus 4 plus 7 root 2. Because we have this negative in front of the parentheses, this negative has to distribute. So 6 plus 7 root 2. Negative times 4 is a negative 4. Negative times 7 root 2 is minus 7 root 2. And you have to make sure you only combine like terms. So the 6 and the 4 can combine. 6 minus 4 gives us 2. And then the other like terms are 7 root 2 minus 7 root 2. 7 minus 7 gives us 0 root 2. And 0 times anything is just 0. 0. So 2 plus 0 will give us 2. So this is an example of taking radical numbers, or sorry, irrational numbers, combining them and getting a rational number as a result. Okay. When you multiply irrational numbers, though, really, we just multiply numbers accordingly. So a really good example of this would be like number 12. Number 12 is negative 2 times the square root of 5 times 7 square root of 3. So really, this is just one big multiplication problem. So you can do negative 2 times 7, which is negative 14. So I just added these guys first. After that, we're going to do root 5 times root 3. And root 5 times root 3, if you multiply two roots, you just multiply their insides, and you get the square root of 15 underneath. And this is an irrational number for your answer. So I hope this was a good explanation. Good luck. And if you have any questions, send me an email and let me know.